Hey folks, welcome to a new video. It's Federico here. In this video we're going to play with texts and JIT geometry and particle systems, and we are going to create exactly this. So we got the text rendered using cubes, and then we make it explode and fall, basically. So to recreate this, you will need to have a max version that supports JIT geometry. I think it's 8.5 or 0.7, I don't remember, but definitely I don't think you need the 9 version. So just to repeat myself, the text is rendered using those cubes, which are positioned with JIT multiple, and then we use a simple particle system to create this explosion effect. We are using ambient occlusion to make the particles look a bit more shadowed, and I just try to render them as spheres. Looks also cool. And yes, that's it. This doesn't only work with text. We could use 3D shapes for that. We could use the duck. We could use every 3D model you like. I will probably do that in a future video. But for the moment, that's what we got. So if this looks like interesting to you, just stick with me and let's jump into it. All right, so as always, let's start from scratch. I'm going to create a JIT world, enable it by default. I'm going to give it floating to keep the window on top of the max patcher. I'm going to give it full scale anti-aliasing, and to give it also a name, let's call it cubes world, cubes underscore world. So let's create our GGL text, which is the object that we will use to generate the text. And if we use the 3D version, this will create 3D text. So I already know that I want the align1 attribute, which means the text will be centered instead of being aligned left or right. So align1 centers the text. And that's it for the moment. Let's create a text like max MSP or something. And of course I had to prepend this with the word text. And there we go. Now to view this text a bit better, let's go and create a GGL camera. I want to animate it so that we can move around in the scene and look at the text from different angles. So I'm going to draw this to cubes world. I'm going to say that it should look at the center, and then I'm going to lock Then I'm going also to say tripod 1. And then I'm going to create a JIT anim drive to actually animate the camera with a UI listen1, which means we'll listen to our keyboard input, and a speed of 20, something like that. So now if I connect the two, I can move around the scene with the WASD-QZ keys, as we always do. And then I want to create an anim reset message, which I will send to the camera in case I want to go back to the original position. Great. So as you can see, the text is three-dimensional, but it's actually pretty flat. So easy, we can visualize it from different angles, but it's flat. So in order to make it not flat, we can set the depth attribute of GGL text to something like JIT 0.5. It's a bit too much, maybe. Let's try 0.4. Yeah, I mean, it's a matter of taste. 0.4 should be okay. We can also change the font. So in order to choose a different font, we can use the font list object, which if you bang it, generates a list of... actually, you know what? Let's go on the help file of GGL text. There is already a font list, which generates this list of fonts with also the prepend font message, which is great for us. So let's just go through them, and we could file through them with an integer. See which one we like. It's a bit difficult. This is cool. Yeah, whatever. I will just choose one randomly. And it doesn't look great because we have no lighting on the GGL text. So what I will do is to apply GGL material to it. So it's now shaded. And it looks pretty good. Okay, good, but we actually want to transform these text into cubes. So we don't really want to use the GGL text for the rendering. We just want to use it for the matrix, which will contain the vertex data for each letter. So let's go here and say automatic 0, which will make the object not draw anymore to the scene, but it will make it output matrices for containing the vertices for the letters. So in order to get that, we should also set the attribute matrix output to either 1 or 2. If we set it to 1, it will output the text untransformed, and if we set it to 2, it will output the text transformed. Now let's just go back 1 second and not set matrix output and actually set this automatic. I want to show you something. As you can see, if we render it like this, by default the text is a bit on top, so from the center of the world, from the vertical center of the world. It's like the bottom of the letters are at position 0. In fact, if we check the bounds attribute, it's pretty cool, has been fixed in max. I think max 9 and or maybe even earlier. So from here we can see what are the extreme bounds of the object. We can see that on the y-axis, the smaller bound, so the bottom bound on the vertical axis is minus 0.02, so basically 0. So this means the letters start from 0. I would like to place that a bit more central. So what I'm going to do, the vertical top is 0.7. So what I'm going to do is to basically detract the half of 0.7 to that and see if we can get it centered. And of course I should put it on the y-axis, not just on the x. And great, now it should be pretty centered. I like it like this. Maybe it's a bit toward, let's see if we get again the bounds. Okay, the bounds attribute doesn't get updated because it only gets the bounds before the transformation. So I think I will set it to something like 0.32. This looks a bit better, a bit more central. Cool. So what we want to do now that we actually transform the text is to use matrix output 2, because this will then output the vertices after the transformation, which is what we want. Now, this outputs a bunch of matrices every time we bang on it, and it's a matrix for each letter. So we want to combine those into a single matrix, because otherwise, let me show you what happens. TGL mesh, draw mode triangles. If we just connect it like this, what happens is that it will just render the last letter, because it takes all the matrices and renders them. The next one will override the previous one. So this is not what we want. We want to basically concat all those matrices together. So in order to do that, we can use the JIT concat object. And what it does is that it basically puts a matrix next to another one. You can put it on the right or left to right, or you can put it horizontally or vertically, right? So basically puts matrices next to each other on whatever axis. And we can use the JIT concat object like this. Let's create a JIT matrix. Let's connect the object to the input of the object to the output of GGL text3, and then its output to another JIT matrix that goes back in its input. So this will create a feedback loop where the matrix comes in, it goes to this other matrix. The first one is concatenated with nothing, because nothing is inside here, or just an empty matrix basically. And then this matrix goes in the called inlet. So when the next matrix comes in, this matrix, let's call it matrix 2, will be concatenated to matrix 1 and then output back into this JIT matrix. And then when matrix 3 comes in, it will be concatenated to matrix 1, 2, and so on and so forth. So if we try that, you can see that it works, but let me show you something. Let's create a JIT FPS GUI to look at the dimensions of this matrix. And now it's 13,000 vertices, and now it's 18. As you can see, it keeps increasing every time I bang it. So to fix that, we should reset the dimensions of this matrix each time we bang the text, the matrix out from the GGL text 3D. So let's try that. And as you can see now, it's always going to be 4,537 vertices, and that's all the vertices we need to recreate these phrase, this word. We could also use, let's just try with something else. I'm just going to try that. And cool, as you can see, this is more vertices because these are more letters, and it's not really, every letter has a different amount of vertices, so it's not linear, the increase, but yeah, as you can see, this is very, this is more vertices. So I will go back to max MSP, kind of like that, as a size. Let's see if we can also use a slash. Yeah, we can also use a slash, of course. So what do we want to do now? We want to transform this text into a bunch of cubes. So to do that, we could use just the vertices as they are. Let's take a look at that. So if we draw those as points, okay, let's make them bigger, otherwise we don't see anything. Point size 20. There we go. So we could use the vertices as they are, but as you can see, they're really not evenly distributed. Some letters have a lot of vertices, some letters have no vertices. So that's definitely not optimal. So what we will do is to use JIT geometry. So JIT geom distribute. So what this does is that you give it a shape and it will place points somewhere on the surface of the shape. We can do it randomly, or we can place them at the centroids of the quads that make up the shape. So if we place them randomly, we will have evenly distributed points on the surface of a 3D object. So that's exactly what we want to do. So we need to convert this matrix to geometry. So we will do this, JIT geom to geom. Actually, we only care about the vertices, so we could also do JIT unpack 1 jump 3 to only get the vertices, and we could do that even before we go in the JIT concat. Right, so once we are on JIT geom distribute, then we just need to go back to matrix, and this we can do with the JIT geom to matrix. So let's place those in between and let's give it a look. And this isn't working. And it took me a while actually to understand why. And I remember that I actually already got this problem once and I solved it in this way. So when you send a matrix to JIT geometry that is not exactly one-dimensional, it will not work. So in this case, the matrix is one-dimensional, but still the dimensions are x by 1. So this by 1, JIT geometry doesn't like that. So we need to get rid of that. And in order to get rid of this by 1, we could just use a JIT matrix and give it 3, float 32, and just do this. So let's trigger the matrix, and then we get JIT matrix info. We'll use JIT matrix info to get the dimension of this matrix. So it will work for matrices of whatever dimension. Then we should just say dim that number. So let's see if we do that. Let's see what's going to be the dimension attribute of this matrix. Yeah, looks like it's just one-dimensional. Perfect. So once we set the dimensions, we should then fill this matrix with these vertices. And there we go. And I click here, and there we go. We got our text made up of points, and they all spread evenly on the surface of those letters. Beautiful. This is, by the way, a system that will work not only with text, but with every 3D shape. Maybe if we have time, we will test it on the duck and some 3D models, but this will work on 3D models as well. Of course. While you were not watching, I have placed a ZL slice here to get rid of the triangles. I thought this was causing a problem, but actually I don't think it's causing any problem, so we can get rid of that. The JIT unpack was actually good, so exactly that should work as well. The JIT geom distribute has a count attribute, which will allow us to set how many of those points we want. Let's say we want 50,000. That's a lot of points. Let's actually hard code that. So count 50,000. Great. And cool. So we are rendering the letter with points, but actually we want to render it with cubes, right? So to do that, we will use the GGL multiple to draw multiple shapes at once, using the position of these dots as the position for our shape. And I think I want to use a cube as a shape, so I will create a GGL grid shape. I will give it dim 8 by 8, which I cannot remember is the minimum amount of vertices for a cube, but let's see. And shape cube. Okay, so this looks like a cube. Let's see how many vertices we can... what's the minimum number of vertices we can have, because that's going to speed up our rendering if we can render it with the least amount number of vertices. So that's 6 by 6, that's 7 by 7, that's still too few. I guess it's 8 by 8. 8 by 8 gives us a full cube. So that's great, and let's set automatic 0, because we don't want the shape to render from itself. We want to render it with GGL multiple. So let's go here. Let's say that this has 3 inputs, or maybe 2. I think we want only 2 for the moment, because we only want scale and position. So GL params are going to be position and scale. Right. And so if we connect these here, and we also need a matrix for the scale, so let's create a JIT matrix. 3, flow 32, and this is going to have the same dimensions as the number of vertices, so basically we could also just connect it here, I think. And once we connect it there, we could also say, want to say that also once the dimensions are set, we want to say set all, like 0.2 or maybe 0.04. Set all 0.4 and then bang the content of this matrix. So we set all the values in this matrix at 0.04, with this will be the value for the scale. And then we bang the matrix into GGL multiple. So let's see. There we go. I think this is now made up of cubes. To better see those cubes, let's attach as well a GGL PBR to GGL multiple. And this looks good. Cool. So now that we have a GGL PBR, we could also use an environment to get some nice reflections on our cubes. So we can do that. So we can get a GGL environment, and we could read a file in it that we could get, for example, from the built-in content in Max, an EXR. We could get the classic photo studio, probably. So I will just drag and drop it here. And then I'm going to change attribute into arguments. This should also hard code the file, but it didn't. So let's go back here, show view by name, studio. So can I just do that? Create a message box, right? So I just dragged and press option, and it gave me this little menu to choose with what did I want to have. So okay, so we have our environment loaded now. Let's also load it inside GGL skybox, or better, let's visualize it with a GGL skybox. There we go. That's pretty fancy. And this is already gamma correction enabled, so what we're seeing is already gamma corrected, and the PBR is gamma corrected as well, so we don't need to apply gamma correction unless we will want to work with some object that don't have gamma correction applied, but at the moment, that's all good. Oh, you know what? We actually need to don't apply gamma correction, because I think I want to use the ambient occlusion pass, and for that we need to have a gamma correction disabled. So, and if you don't have an idea what I'm talking about with this gamma correction stuff, I invite you to read these articles in the Max documentation about color, gamma correction, and a lot of other cool things. I will put a link in the description. So anyway, if we want to do some further processing on images, we always need to set gamma correction to 0. And then what we want to do is to create a GGL pass, fx name gamma, and maybe set the quality to high, which means it will use float32 textures, which is the highest amount of bits we can have per texture, and these will look possibly better. And I also wanted to create a GGL pass, fx name ss ambient occlusion. So I don't know what ss stays for any again, but this is basically ambient occlusion. So the cube should look a bit more shadowed. Screen space ambient occlusion, that's what the ss is for. And it looks pretty good, actually. I just created it. And look, it's beautiful. Let me just set the quality high. I'm checking my previous patch as I did it. And we want to connect these here to say, okay, this pass is first and this one is later, because the gamma correction must be applied as the last element in the chain. The screen space ambient occlusion has a bunch of parameters like the radius, which we could use to... I'm not sure what's the best values. I didn't play super extensively with the screen space ambient occlusion. So there is also temporal ambient occlusion, which possibly looks better, but this has this grainy kind of texture, while this doesn't. So yeah, we will go with this one. Great. Let's just try to scale those cubes smaller, and so we can see the individual cubes. That's also fine. That's also great. Okay, cool. So now let's start to actually move those cubes. We are going to do that with the CPU. So we're going to use JIT GEOM to... Let me give you a panoramic of the patch as it is right now. We're going to use JIT GEOM to move those vertices in the CPU. So that's something that GGL Multiple understands. And we could do these also on the GPU, but we will need to use instanced mode of GGL Mesh, and maybe we will do it in a future tutorial. But for the moment, it's definitely fine and great to use the CPU. The frame rate is going to be probably fine. So let's actually check the frame rate with JIT FPS GUI. This time to actually check the frame rate. And there we go, we're running at 50 frames per second. That's probably also because I'm recording this while it's running, when it's taking some toll on the computer. And it's also, we have 50,000 cubes, which is a lot of cubes. So good, let's start to move them. Let's create a JIT matrix. And we're going to create this basic particle system idea, which I showed already in a lot of videos. I will put also a link in the description to a series of videos about particles I made. This will make everything much clearer if you don't really know what I'm doing with the particles and vectors, with forces and vectors and these sort of things. So if you're confused about this stuff, I invite you to check that video, but I'm also going to explain you as much as possible what I'm doing. So let's create a JIT matrix, call it mat position, and let's connect it to a JIT GEOM, and let's also duplicate it like this. And why I'm doing that is because when two matrices have the same name, they share the same values, the same content. This means that once this matrix is updated, the new content is placed inside this matrix, this same content will be in the matrix above. And this creates a feedback loop, which then we can use to move objects using forces and not just using parameters. So inside here, let's try, for example, to make these particles fall down. And we can do that by summing this position of the particles to a vector. 0, 0, minus 0.001, 0. And we just will sum this position to this vector, and you will see that nothing happens because we need also to bang this matrix. So when we bang this matrix, And of course, this matrix is empty because I first need to fill it. So when we bank this matrix, you should see that the position of this should go down. I'm not sure if it's because this is too slow. The number is just too small. I think it's very small, so let's make it bigger. Yeah, there we go. And now they start to fall. So let's automate this banging, and we can do that by using JIT bang, which mirrors the bang that the JIT world outputs at each frame. And woo! Particles are falling. Now let's make this a bit more interesting by using a JIT noise to randomize the rate at which the particles are falling. We can connect it to the same dimension here. This is the number of vertices we got. So once we set the dimension, we also want to bang it. This is going inside the input too. Let's give a title to this JIT gen. Let's call it particles forces or something. And this we don't need to bang the JIT noise every frame. We just want to use it as a fixed value that is a random fixed value, right? We could use the noise generator inside JIT gen, but this will give us a different value for each frame. And that's not what we want. We want to use a fixed value that is there at each frame is the same. So what we can do with that is then multiply, for example, widths. So get the x component of this noise and multiply the vector by this. This will be the amplitude of this vector. And let's bang again here. And as you can see, now the particles will fall at different speeds, which is pretty cool. It's like melting max thing. So every time we bang here, it will start from scratch. Now you can appreciate that those particles are all falling at the same, so a single particle will keep its falling speed constant. And that's not really how physics work, because gravity is a force that makes you accelerate, right? Each second an object on Earth will accelerate 9.8 meters per second, something like that. So these objects, these cubes are all going down at the same speed. There is no acceleration. And in order to achieve that acceleration, so a bit more kind of physically correct, we have to introduce a new value at each frame, which is the velocity of the cube from the previous frame. So let's create a new input and let's call it velocity. Just a comment to remind us what this is, what this input is. It doesn't do anything, the comment. So this will be position. And so this is our velocity at this frame, basically. And we're going to sum this velocity at this frame with the velocity at the previous frame. So going to do this. And then we are going to output this. This is the velocity out. Going to output this. And you guessed it, we need another couple of matrices for the velocity. So JIT velocity, this works the same way as the position. They will store when the matrix is output, the content of the input matrix is the same as the content of the output. So this creates the feedback loop. And we also want to set the dimensions each time. We can do these. Actually, we could use a single trigger bang for all of that. That bangs all of these matrices. And so let's give it a try and see what we get. And of course, we need to actually bang these matrices as well. And that's not it. So, okay, I forgot to sum these to the position. So, whoa, okay, that was fast. As you can see, the particles are now falling much faster because they are accelerating at each frame. At each frame, the speed at which they are going down accelerates. So let's actually move the whole GGL multiple up there, something like that. And then let's also diminish a lot the rate of acceleration So the force, so this will start really small, and then slowly it will keep on increasing linearly the speed of the particles going down. Now this is way too slow, so I'm going to make it a bit bigger. We can experiment a lot with that. Can make it 10 times faster, for example. And then I also probably don't want to have these, I don't want to have these banged all the time. I want to probably be able to enable it and disable it. So I can just set the text, enable these, and start the animation, right? Okay, that's cool enough. Let's see what else we can do with the particles forces applied to cubes and text. So, for example, I would like to have these particles explode from the center here of the text toward like a spherical explosion that will push particles in all directions. Sounds pretty cool. So let's see how we can do that. I think we can do that by setting an initial velocity for the particles, and this velocity should be the explosion force. So let's create another JIT gen and call it title explosion force. What did I write? Okay, it's correct. And let's send a JIT matrix into it, which is 3 planes, flat32. Or actually, you know what? We don't need a new matrix. We can use the matrix that comes from here, the position matrix. So the cubes pos matrix, or actually mat pos cubes, right? We can send these here, and we can receive it. We can receive it here. So inside here, what we want to do is to create this initial velocity for the particles. So what we want to have is, we need to create a vector. And let me see, I got something fun. Right, paper, crazy. So let me see. We got the particles. Let's just visualize them as cubes or dots. And these are all scattered in all positions. And then we want to have the explosion coming from the center of the text. So that's going to be the explosion center. So we need to get a vector that from the center goes to each particle, right? And then we need to normalize this vector and apply these as a force to all the particles in a certain area. And okay, cool, that should be it. Let's see how we can do that. Okay, so let's implement this in JIT gen. And to create a vector that goes from the center to the vertices, that's just basically the position of the vertices, because this will be the position minus, and that's by the way the origin cube position. And so this would just be this position minus this vector 0, 0, 0, which is basically just a position. So we can normalize that. Or let's just try to not normalize that. And let's see what we got if we do this. That's probably going to be pretty crazy. So I don't know if it's going to work. Let's just try to click here. And whoa. Oh, sure, I need to enable it. And poof. There we go. So let's try again. Okay, so there are two problems. The first problem is that the first position of the particles is set already, summed to the force of the explosion, the vector of the explosion. So what we should do instead is to pass first this matrix here to set the position here, and then we should also pass it directly to the GGL multiple. So it will be first set through the calculations here in JIT gen, and then it will also set by using the original positions. So let's give it a go, and there we go. Now if we click enable, we should see the explosion. Boom! Right, and they exploded. It's bit annoying to have to go up there all the time, so I will just create here a start bang so that we can press it from down here and receive it there. So start bang, enable, boom. Okay, cool. This is of course way too big of a force, so let's try to multiply it by something small, see what happens. So we're not normalizing this vector, which means these vectors, which means that each particle will receive a bigger force according to its distance from the center. So particles that are far from the center will receive a bigger force, which is probably not actually cool. So in order to make it a bit more interesting, let's normalize this vector. And then let's divide this vector by the distance between the cube and the center of the 3D world, which is basically just this vector. And so what we want to do is to divide this by this vector, summed with something very small in order to avoid the division by 0 if the particle, the cube, is exactly at the center of the world. So we want to do that. And okay, let's just try to do it like this. Oh, right. Sorry, silly me. We don't have to divide this by a vector. We have to divide this by the length of that vector, which is how far is actually this cube from the center of the world plus this little offset. Let's give it a go. So start, bang, enable, boom. Okay, so that's way too strong. It's way too big. So let's multiply it by something like 0.1. See what we get. Probably still too big. Okay, we're getting somewhere. It's way too big. Still the force, but as you can see, there is like this circular, this spherical explosion that is exploding from the center and is affecting mostly the particles close to the center because they get divided by the bigger number, the smaller number, sorry. And particles that are farther are divided by a bigger number, which then makes them not so affected by the explosion force. And boom, cool. That's pretty cool. So let's give it another try. Boom. Okay. Look, we're getting somewhere. One thing I'm noticing is that the explosion gets all the way only to the back and not toward the front of the text, which means since we are subtracting this to the center of the world, it means that all the particles are actually only on the negative axis. And let's see the bounds here to see what is the zeta value of those. So they're only on the positive axis, which means we should probably, so that's the zeta value, right? Oh, is this the zeta value? No, the zeta value is 0. And here is minus 0.4, right? So they're only on the negative side of the world, which means we should probably set our center of explosion here, something like minus 0.2, to have it halfway. And now we get a spherical explosion, as I was envisioning. Cool. Let's make this a bit smaller, like half of it. Okay, that's awesome. We can add a bit of friction with the air to have those particles like losing the momentum faster than this. So we could multiply the velocity here by 0.95 instead of just by 1, and this will make them fall. This will make them like explode and then slow down faster. Like if they have a lot of air attrition, like if they're actually made of a very light material that has a lot of air attrition with the air. So let's give it a look. And I also increased the falling speed, by the way. Yeah, that's fine. Make them fall faster. And let's make these bigger. Let's make them fall faster. And let's see. Boom. Cool. I like it. Some particles will never fall because in this gen here, the noise sometimes is 0, which means their speed is always going to be 0. So actually, let's reduce a lot the influence of this noise. So let's assume they don't have also different speeds or masses, for example, but they all have kind of the same mass plus minus 0.2, right? So we apply an offset of 0.8, multiply the noise by 0.2, and see what's going on. Right, so they kind of all fall at the same speed now, which is probably more accurate. It would be cool to have them first exploding and then falling. For that, we will just need to implement a simple parameter. Let's maybe try to get the... I will get the gravity away, but I just realized that we should multiply this by the noise after we... so as the explosion force as well. And then we should add this to that if we want. But the explosion should also be multiplied by this noise. And yeah, this looks pretty cool. Like we have all these particles. Let's make them smaller. So scale here. I want to get the cube smaller. So what we can do is to set this to 0.01, and now they're smaller. I want to make the explosion force bigger. This is all stuff that we could change with parameters, right? I'm just changing it by hand now because it's more convenient. But we could do it by hand. So let's see the explosion, boom. Okay, so that's pretty cool. And then let's add the falling force to these. Multiply by the noise as well. Right. So let's see. Cool. Let's maybe make the falling force small. I could tweak these for hours. And maybe accelerate also the... reduce the air friction. Okay. I think I'm gonna stop here. This is kind of fun. For the moment, I'm pretty satisfied. This video is already pretty long, and it's pretty cool. It looks pretty cool. It's something you can start to play with. Sorry, I just want to make the explosion force bigger. That's the last thing I'm going to do, I promise. Boom. Okay, good. Thank you very much for following through this. I hope it was interesting. I hope it was not confusing. If you have questions, post them on the comments. Watch all my other video tutorials that I will put in the description. And yeah, I got also many more on the basics of Max, advanced things in Max. So if you are interested in learning jitter with Max MSP, take a look at my channel. And take a look at my Patreon, where I share patches. I will share this patch for this video. I share patches that I'm making since 10 years or so. They are all on my Patreon for a little subscription, monthly subscription. You can also subscribe to once, can get out of it as fast as you can. That's also an option. So in any case, thanks you so much for watching. If you decide to support the channel, that's great. If not, that's also great. And I hope I will see you in the next video. Take care. Ciao.